Hello guys, welcome back to another video. We are asked to evaluate the following integrals. Integral from 0 to 1, x to the fourth, ln of 1 over x, everything raised to the power of 3, and the integral from 0 to infinity of 1 minus e to the minus y, multiplied by y to the power of minus 3 over 2, sorry. It should be 3 over 2 because it wouldn't converge otherwise. Okay, to the power of minus 3 over 2. So we are asked to evaluate those integrals. Okay, let's begin with the first one. Okay, let's do the first integral from 0 to 1, x to the fourth, ln of 1 over x, everything to the power of 3. Okay, what will I do in this integral? Which substitution will I use? I will use the substitution ln of 1 over x equals y. You're asking me like, why do you do this? Like, you will see. You will see in a moment. Okay. When we do the derivative, 1 over x is just x, and the derivative of inside is negative 1 over x squared equals to dy. So this is what? Negative 1 over x equals to dy dx here, sorry, dx here too. So dx is equal to negative x dy. Okay. Okay, now what? We need to solve for x, this equation. We need to solve for x. So from this we can get negative ln of x equals to y. When we put the negative sign there, we get ln of x, the minus, okay, sorry, to the minus y. When we do to the power of e, we get x equals to plus e to the power of minus y. Okay, this is what we get. Okay, this looks weird. So how do our boundaries change? Our integral was going from 0 to 1, but when we put 0 here, we get infinity. So this is infinity, 1, ln of 1 is 0, so 0. When we plug x here, we get e to the minus y raised to the power of 4. Okay, to the power of 4, and ln of 1 over x is replaced with y, so y over 3, y to the power of 3, sorry, and the dx is negative, or x, we solved for it, so it's e to the negative y dy. Okay, so this is what we have. We will use this negative to flip the boundaries, so we get the following. This equals to from 0 to infinity of what? We will have e to the negative 4y, y to the power of 3, e to the negative y dy. Okay, what will we do now? We will combine the e's and see what we do after. From integral from 0 to infinity, e to the negative 5y, y to the 3 to the power of 3 dy. Okay, why are we doing this actually? So I will tell you in a bit, but first let's introduce the substitution. phi y equals to t. From this, phi dy equals to what? dt. dy equals to dt over 5. So our integral, okay, again, our boundaries don't change. If we put 0, it's 0. If we put infinity, it's infinity. So it stays the same. Or okay, so we replace phi y with t. So we get e to the negative t. Y, we need to solve for y. So y equals to what? T over 5. Okay, we get t over 5 to the power of 3. This is what we get. And dy is just dt over 5 d, okay? We get 5 to the power of 3, and this 5 we get 5 to the power of 4. From 0 to infinity, e to the, okay, sorry, the better e to the power of negative t, t to the power of 3 dt. Okay, so what is this actually? This is the reason why we actually did this. There is a function, special function called gamma function, defined as follows. Gamma of z from 0 to infinity, e to the negative t, t of z minus 1 dt is just n minus 1 factorial. So, like, and now you're asking me what is this t to the power of 3? Okay, let's solve it. Like, and what do I mean with let's solve it? We know it must be of the form z minus 1. So let's solve it for z or for t or whatever. Like, let's put it like this. T minus 1 equals to 3. This is the form. It is for this is the form for which it is defined, and we have the degree of 3. So we just can make a basic equation, and we solve for t. It is 4. So we have the gamma of 4 actually. Okay, this equals to gamma of 4 over 5 to the power of 4. And now what is gamma of 4? Here is the definition. Gamma of 4 is n minus 1. What is n? 4. So what will we get? We will get 3 factorial. And what is 5 to the 4th? It's 25 times 25. And this equals to 6 over 625. And now you're asking me, but we could have done this without this special function. I agree, but it would take some partial integration or some things that are not so easy to do. I mean, it isn't that easy to do partial integration. I mean, it is solvable, but this is a faster way to do it. Okay. Now let's do another integral. Okay, an integral. This one we will do it like so I don't have much space. So let's do it like here, which equals to that. Okay, we have this and this. So what can we actually do? Like you can see that this problem is a bit different. So maybe we have to do some more work than just do a simple substitution and that. So it turns out like we should use a partial integration here, but I don't think this integral is solvable by normal means. Like you have to the power of negative 3 over 2. If you do partial integration, that won't go away, I think. So what will we do? We will take the derivative of 1 minus e of 1 minus e to the negative y, and y to the power of negative 3 over 2. We will, okay, we will integrate this, we will differentiate this. What do we get? We get negative e to the negative y. What do we get here? When we do the integration, we get plus 1 on the top, and it becomes y to the negative 1 over 2, and divided by that. So we get negative 2 to the y to the power of, okay, negative 1 over 2. I hope, okay, sorry. I hope you can follow me on this one. I think it's okay. It's a basic thing. Okay, so when we do partial integration, we do this minus this. So let's see what we end with. Now let's see what happens now. Okay, so what happens now is we get 1 minus e to the power of negative y times negative 2y to the power of negative 1 over 2. We get this evaluated where? From 0 to infinity, and now we connect those two, plus 2, an integral from 0 to infinity, e to the negative y to the power of minus 1 over 2 d. Okay, when we put 0 here, we get 0 times 1, 0 times e to the 0, it's 1, so we get 0. When we put infinity, this is, okay, we combined this and this. Okay, let me see. Okay, it's correct. When we put infinity here, like this will go will go negative infinity, but it's to the negative power. This will go down. This is 1 over, like 2 over infinity times this or times this. This also goes to infinity. So this thing evaluates at 0. So we are left out with 0 plus 2 times the integral from 0 to infinity. Let me write this better. E to the negative y to the minus, okay, y to the minus 1 over 2 dy. And now what shall we do? Like we again have the similar situation to this. We have, like, this is the form z minus 1, but we have minus 1 over 2. So what should we do? Let's do it like here, like minus y minus 1, this is similar to this, equals to negative 1 over 2, y equals to 1 minus 1 over 2, y equals to 1 over 2. So this is actually gamma of 1 over 2. I can prove why is this result gamma of 1 over 2 is square root of pi. I can prove that, but in another video it will get too long. So this actually equals to 2 square root of pi. So our integrals are solved and our video is over. So guys, I hope you enjoyed this integral battle. Like, share and subscribe if you want to see more of this, and see you in the next video. Bye guys.